Hello, thank you very much for the opportunity today to share with you a proposal for a database project to manage post-procedure death rates within a hospital system. My name is Elizabeth Lafortune, and it's my pleasure to speak with you. In this presentation, I will provide an outline for a hospital implementation of a database management system to address the inefficiencies in monitoring and improving patient care related to post-procedure death rates among healthcare providers. The development of a comprehensive database system will enhance efficiency in collecting, compiling, and reporting clinical data. The system aims to fill an existing gap, providing healthcare professionals with a robust tool to streamline the management of post-procedure death rate data. Ultimately, this project seeks to contribute to improve patient care by offering more effective means of monitoring and analyzing clinical information. This slide introduces the topics that will be covered in this presentation. This presentation applies the principles of the systems development lifecycle. The 5 principles are planning, analysis, detailed systems design, implementation, and maintenance. As part of the planning process, the project problem will be identified. The role of the proposed project will be communicated. Also, the goals or measurable objectives will be outlined. Secondly, the analysis phase will include a discussion regarding the requirements of the database users, their role and competencies. We also take a look into the data that will be collected and reported and the reports generated from the database. Next, in the detailed systems design phase, we will have a conversation regarding technical specifications, the database's data dictionary, the ERD diagram, and training principles. The implementation process includes visuals on the database functions and outcomes, as well as a discussion on assuring the security, privacy, and integrity of the database. A dialogue will be had regarding potential problems and barriers. Finally, the maintenance phase outlines what comes after implementation for the life of the database, including upgrades and enhancements. In the United States, at least 100,000 people die annually following elective surgeries. As a part of the planning phase of the SDLC, the purpose of this database project is to address the inefficiencies in monitoring and improving patient care related to post-procedure death rates within the healthcare system. The development of a comprehensive database will enhance efficiency in collecting, compiling, and reporting clinical data. The system aims to fill the existing gap, providing healthcare professionals with a robust tool to streamline the management of post-procedure death rate data. Ultimately, the project seeks to contribute to improve patient care by offering a more effective means of monitoring and analyzing clinical information. The project goal is to develop a comprehensive database system for collecting and reporting clinical data related to post-procedure death rates. The project objectives include implementing a user-friendly data entry process for healthcare providers to input accurate patient information within 6 months. Also, a project objective is to generate customizable reports and analytics for healthcare administrators to analyze post-procedure rates quarterly. Lastly, our objective is to ensure data security and compliance with healthcare regulations by implementing encryption protocols and role-based access control within 9 months. The steps to meet these goals and objectives will be to conduct a thorough needs assessment and workflow analysis in collaboration with healthcare professionals. Then we will design a database structure and user interface based on the identified data requirements. We will conduct extensive testing and validation to ensure the accuracy and reliability of the database system. And finally, we will provide comprehensive training for healthcare staff on data entry, reporting, and data security protocols. This wraps up the analysis phase. As we move into the analysis phase, we will discuss the users. The database users include healthcare providers, administrators, data entry staff, and IT administrators. Healthcare providers must have competencies in patient care, medical record documentation, and procedural knowledge. These providers are the stakeholders and end users and provide valuable insight to the project during this analysis phase. Healthcare administrators must have a background in healthcare operations and management. Data entry staff must have training in data entry and management procedures. Finally, IT administrators must have expertise in database management and security protocols. These professionals typically are familiar with the use of a database management system and data entry, so minimal to moderate training will be necessary. We will touch base on training in a later slide. Data collection will include patient demographics and medical history, procedural details and complications, and contributing factors to post-procedure deaths. A post-procedure mortality trend analysis report will analyze trends in post-procedure death rates over a specific period of time, enabling healthcare administrators to identify patterns and potential risk factors. Second, a complication-related death report provides a breakdown of post-procedure deaths linked to specific complications, assisting healthcare providers in understanding the impact of various complications on mortality. Third, a procedure risk assessment report evaluates the risk associated with the different types of procedures, aiding physicians in making informed decisions regarding patient selection and procedure planning. As we move into the detailed system design phase, the database structure relies on SQL with tables for relevant entities. The data dictionary is comprised of 5 entities. On this slide, you see patient, physician, hospital, procedure, and on the following slide, outcome. The appropriate data types are defined for each attribute, for example, date, characters, etc. The database is designed to handle a potentially large volume of data, considering the scalability requirements for future expansions. The database performance is optimized through indexing, query optimization, and regular maintenance to enhance efficiency. An ER diagram provides a visual representation of the database structure, helping stakeholders, including non-technical individuals, understand the relationships easily. The simplified complex data structure makes it easier to identify key entities, relationships, and attributes within the system. ER diagrams facilitate effective communication between stakeholders, designers, and developers, ensuring that everyone has a common understanding of the database structure. The ER diagram you are viewing now is in Chen notation, and the relationships in the database proposal are: a physician can perform multiple procedures, but each procedure is performed by exactly one physician. A patient can undergo multiple procedures, but each procedure is undergone by exactly one patient. 3, procedures take place in one hospital, but a hospital may host multiple procedures. Each procedure has one specific outcome, and an outcome is associated with exactly one procedure. The outcome entity includes information about the procedure's results, such as whether it was successful or resulted in death. Various training opportunities will be available. Hands-on training sessions will focus on navigating the user interface, emphasizing how to access different sections and data within the database. Users will be instructed how to run queries and generate reports to extract relevant information from the database, emphasizing the use of filters and parameters. Users will be educated on security protocols, including password policies, access control measures, and the implementation of safeguarding sensitive patient data. We will establish clear channels for user support, including help desks, frequently asked questions, and online forums to address any queries or concerns users may have during their interaction with the database. Here we enter the implementation phase. Using SQL, the procedure table is created using the create function. Here, the alter function is used to add a column, procedure date, to the procedures table. Here, the insert into function is used to add a row to the procedures table. Here, a query table statement is used to display a list of providers and procedures from the procedure table. Here are query columns, which are used to display the sum, average, min, and max. Here's a query aggregation, which is used to display unique physician IDs in the procedure table. Here is a multi-table query, which is used to display data from two tables. Here is a multi-table join query, which is used to join data from two tables. As a database administrator, enforcing data security, privacy, and integrity involves managerial activities. Some key tasks include user access management, authentication and authorization, encryption, backup and recovery, and auditing and logging. User access management involves creating and managing user accounts with appropriate privileges. Authentication and authorization involves implementing strong authentication mechanisms and defining and enforcing access control policies. Encryption must be implemented for sensitive data to protect it from authorized access. Establishing regular backup routines will safeguard against data loss, and enabling auditing features to monitor user activities and detect any suspicious behavior is needed. Project barriers include resistance to change among healthcare personnel accustomed to traditional data collecting methods. Overcoming this resistance will require effective training programs and communication. Also, there's a potential for integration challenges within existing hospital information systems. Ensuring seamless interoperability between the new database system and other applications is vital for cohesive healthcare information infrastructure. Data quality and accuracy must be ensured to avoid compromising the reliability of the database. Healthcare data is sensitive, and robust security measures must be taken to protect against breaches. Finally, potential data privacy concerns and compliance issues must always be considered. It is assumed that healthcare staff will adapt to the data entry and reporting processes with the necessary training and support. It is also assumed that adequate resources will be allocated for the development, implementation, and maintenance of the database. Maintaining a database for post-procedure death rates involves various ongoing tasks to ensure its optimal performance, security, and reliability. The database will periodically optimize for performance by analyzing and improving query execution plans, indexing strategies, and overall database structure. The database software will be kept up to date with the latest patches and update to benefit from improvements in functionality, security, and performance. We will monitor database growth trends and plan for increased storage or performance requirements. We will establish mechanisms for collecting feedback from users and administrators to identify areas for improvement and address any user concerns promptly. The development of the proposed database system will significantly enhance the ability of healthcare facilities to monitor, analyze, and address post-procedure mortality rates. By enabling comprehensive data collection and analysis, the project will lead to improved patient safety, informed decision-making, and targeted interventions to reduce mortality rates. Despite potential challenges, the project's feasibility lies in its potential to streamline data management, facilitate evidence-based practice, and ultimately enhance patient outcomes within the healthcare setting. The database meets the regulatory compliance standards of safety and reporting. Time and money will be significantly saved with the reduction of manual, time-consuming tasks and reduced paperwork. Also, enabling proactive measures and interventions to improve patient outcomes will ultimately reduce costs associated with complications. Finally, this is my reference page. These references support the information presented in this project. Thank you for listening to my database proposal for post-procedure death rates. I appreciate your consideration and welcome any concerns you have.